Hi, myself Mr. A. Balachandran. Now we are going to see the dynamic latches and registers for the course VLSI and chip design. Dynamic logic, it is a temporary storage device. Its output levels will be remain only for the particular period, or it is periodically it is refreshed. The another version of the dynamic latch or another version of the latches and registers are the static latches. In the static latches, the output values are retained as long as the power supply is on. Whenever the power supply is off, the static latches will restored to its previous values, or it is restored to zero. This makes the complexity in the computational structure of the pipeline data path. The circuit becomes complex and its area or power, everything is become heavier in this technology. So we are here, we are going for a dynamic logic circuits. This dynamic logic circuits be worked based on the dynamic logic circuit working based on the pre-charge and evaluate phase. In the pre-charge phase, the capacitance of the inverter is charging and it holds the value. In the evaluate phase, the selectively the capacitance will discharge based on the it input values. Dynamic latches with a single clock. Here in the dynamic latch, we are neglecting the feedback leg. That is, the data will be stored on the capacitance of the inverters by switching the charge in and out. So the minimum frequency of operation is typically of the order of 50 to 100 kilohertz is required uh, to make sure that the loss of data is very minimum at the junction capacitance or due to the leakage current. It can be clocked high frequency since a very little delay in latch elements. Uh, these are the sum of the gated latches. The figure A and B shows the simple transmission gated D latch, and C shows that the inverter with a high impedance tri-state inverter high impedance D latch. The D and E shows the dynamic D latches. This is a transmission gate, and here we have used the two transmission gates and two inverters. That is the same in the CMOS logic. The basic major principle of operation of the dynamic register is it will store the temporary storage of charge on the capacitors. Its stored value is only kept for a minimum period of time. So to retain its value, the periodical refreshment is required is for the dynamic register. That is for to preserve the integrity of the signals. So this can be used in the computational structures of pipeline data path. Yeah, this is the dynamic positive edge triggered register, which we have seen in the previous slides of D and E diagram. This is the transmission gate, and this is the inverter one. This is transmission gate 2. This is inverter 2. Here we have used the two capacitance C1 and C2. That is, this one is a master circuit and this one is a slave circuit. So in the master also we are using the capacitor and for the charging and discharging. In the slave also we have used the capacitor for charging and discharging. For that is in digital we can say that storing the value of 0 and 1. Whenever the clock signal is 0, the capacitance at the T1 holds the value of the gate capacitance of I1 and junction capacitance of T1 and leakage capacitance of the T1. At the time when the clock is 0, that second phase, that is slave circuit, is in the hold state because there is no data to propagate, or there is no signals is given to the slave circuit to propagate the data from the master. Where as long as the clock is 0, the capacitance 1 will holds the value of the junction capacitance and leakage capacitance of the T1 and gate capacitance of the I1. When the edge is crossing the positive, that is when the clock signal is crossing the edge, positive edge, the second phase, that is slave circuit is switched on and it propagate the master data to the Q stage, that is D latch is attained. This is how the positive edge triggered register is working. So the main advantage of the dynamic delatch using the transmission gate is it only requires the 8 transistors. But when we use in the NMOS transistors, it requires only the 6 transistors and low power, and it produces a low power propagation delay. That is one pass transistor delay plus one inverter delay is enough. That is the propagation delay for the dynamic delatch. The limitations. Always the limitations are there in the digital world. Here we have the overlapping for the small part of time. Here we have used the clock and the clock bar signal. So whenever the input or clock changes from the one state to another state, there is a small fraction of seconds. It is in the maybe in the microseconds or nanoseconds. Both the clocks are in the same value. That is, both the clocks are in the 00 or 11. So these two conditions can be occurred here also. So during the 00 overlap data path, the data from D to Q will be passed through the T1 PMOS and T2 PMOS. During the 1-on overlap, direct data path will be exit from the D to Q through the T1 NMOS to T2 NMOS. So the data path, that is the overlapping, can be overcome by using the clock skew insensitive C2 MOS register. Here we have used the 8 number of transistors in the master stage and slave stage by combining. Here the operation of this clock skew insensitive C2 MOS register is whenever the 00 overlap occurs, M2 and M4 is on and X is changed its value, but it does not propagate its value to the output. Whenever the clock changes to its original value, the data will be propagated from X to output through the M5. Similarly, for 1-1 overlap, M1 and M3 will be used to pass the master data to the M6. Clock and clock bar, that is for a clock skew insensitive C2 MOS register. If the D input changes during the overlap period, node X can make a transition, as I said earlier, but cannot propagate to the output. However, as soon as the overlap period is over, the PMOS, AM and NMOS for the respective overlap, 00 overlap for PMOS, 1-1 overlap for NMOS, and it propagates its value to the output. However, this effect is not desirable. The problem is fixed by imposing a hold time constant on the input data. Or in other words, the data D should be stable during the overlap period. This is the another disadvantage of using the clock skew insensitive C2 MOS register. Uh, that is, as I said earlier, that is propagated in the graphical method. The another way of the overcoming the dynamic delatch is dual edge registers. This is the circuit diagram of the dual edge registers. That is input sampled on both edges, that is positive edge and negative edge. Lower frequency for same functional throughput. That is in the case of the dynamic delatch in ideal, that is which uses the transmission gate, it requires an high frequency, that is 50 to 100 kilohertz. But here when we using the dual edge registers, it requires only the low frequency paths, and it also is in the power savings mode also. Then another version is a true single phased clocked register. When clock is low, if data is 0, if clock is low, data is 0, node 1 is charged to high, node out is in its previous value, because there is no signal to propagate the data from the master to slave. If the data is 1, node 1 is retain its previous value, and node out is also retains its previous value. When clock is high, the chain of two inverters latch is transparent and Q slaved to D. The same structure, the two-phase clocking scheme care must be taken in routing the two clock signals to ensure that overlap is minimized. This register can be constructed by cascading the positive and negative latches. The main advantage is use of the single clock phase, which overcomes the problem of the overlapping. This is the positive edge triggered register true single phased clock. And its working is based on when the clock is 0, and for that the input inverter is sampling the inverter D input to node X. The second inverter is in the pre-charge mode. As we know that dynamic latches are working in the two phase, that is pre-charge and evaluate mode. In the second inverter is going went into the pre-charge mode, that is it will charge from charged to VDD. The third inverter is in hold mode since M8 and M9 transistors are in off condition. And when the rising edge of the clock, the dynamic inverter M4 M6 evaluates, that is it went into the evaluate phase. If X is on the high rising edge, Y discharges, that is third inverter M7 M8 is on during the high phase, under the node M8 M7 M8 is on during the high phase, and the node value on Y is passed to the output queue. Thank you.